This video is on plant interaction and limitation of growth. What I want to do is talk about a variety of things that influence how trees grow and how groups of trees grow. And the first thing we have to appreciate the fact is that certainly is that change is happening all the time. Stand structures change over time, and that's of course over long periods of time. Sometimes it could be as short as 80 years, there's a fire, or it could be as 300 years. It all depends if it's a rainforest, a boreal forest. It all depends on where it is growing. So one of the things we're going to be talking about along the way is what many times we're going to be using the word stand. And stand, a forest stand means is a spatial continuous group of trees and associated vegetation having similar structures and growing under similar soil and climate conditions. And that sounds very complex, but really when you look at it, when you look at a forest stand, you can see it because it is a group of trees of similar nature. And then when we get into the we look at that particular stand which has the similar characteristics, we will see that the stand structure is another thing we will talk about. So for an example here, we could see the stand structures that we have lower trees here, and then we also have some taller trees over here, and all that refers to is the structure of the stand from the plants on the ground to the overstory. So that's the type of things we want to address. Now, one thing is that we want to do is look at, from a historical perspective, how have stands been evaluated. And in the past, what we have found is that it has been perceived that the forest stands have been perceived in many different ways. And one of the ways is that the forest stands have been perceived is under the idea of a superorganism. The idea that the whole forest is an entity that works together, much like a human body. And the idea is you take out one thing and the entire thing shall collapse. And that is not correct. A forest is not a superorganism, but more or less it is made up of individuals who are able to compete and survive in one area. The other kind of belief is that a forest can reach a steady state or climax or old growth, that all forests reach this point and then they don't ever change. That's not true either. And that ties in much into the belief that there's a balance of nature. And so all of these are kind of a belief systems that have occurred, and they're found throughout the literature, but they're not correct. The truth of the matter is that what we have in forests is that we have the idea of this is brought out in many of the discussions. Is it mutualism or competition among species? And mutualism implies that everything has to work together. And then the quite honest truth about it is that a forest, it is very much all about competition. And when we look at it, and much research has been done on it, when we look at tree interactions, we see certainly the influence have been more about competition. And to give you an example of this, if you look at behavior of managed and logged stands, after an area has been logged, what you will find is that the species which is the most, can take the greatest advantage of the certain climates, soils, wind conditions, moisture levels, will win. It is not a situation of a particular tree species will grow there again because it was there before. There's no guarantee. The next one is that as situations change, and this ties into our global warming actually right now, we're finding that species are migrating more north, and that is the more southern species are migrating more north. And why are they migrating north? Because they're able to compete better with their characteristics now that there's a bit of global warming occurring in the forest community. Yeah, and this has also tied in directly to recent introduced species that are competing. And for example, European buckthorn grows well here. It is not part of the original forest, but why does it survive so effectively? It's not because of mutualism, but because of its ability to compete. And we're seeing that on a very significant level. In regards to age distributions within a stand, you see that that in a strong basis, and we'll be explaining that in more detail along the way. So age distribution implying what you will see in a stand structure of different species. So, and we'll also be discussing disturbances in further detail. So we know then therefore that competition is what drives a forest, not mutualism. And here we have a picture, and you can see we have different structures, and all these structures in the forest have been influenced by the competition between the tree species. So where are plants found? Well, it's not predestined, that's for sure. And it's not, and what that means is just because, as we have discussed before, a tree is harvested, a white pine, for example, is harvested at one point. Will you find white pine there again? No. It is influenced by many factors. And one of the things that is greatly influenced by is by the regeneration strategy. For example, you could have a white pine forest, and you harvest it, and you may have lots of, you feel that, well, there should be a white pine coming back because there is it was white pine stand. And what you could find when you come back after an area was harvested, or there was a fire occurred, a big blowdown, natural occurrence of a calamity, you come back and discover it's all pin cherry. And because the cherry is able to regenerate very effectively after a fire, or it's all jack pine or lodgepole pine, which are have effective means to regenerate after a fire. So that can greatly influence, the regeneration technique can greatly influence how trees respond to disturbance and how they regenerate an area. The other one is the physical environment. How dry, how wet is it, and what aspect? That can greatly influence how trees will establish themselves. One thing is that on the ground, we sometimes think of that the forest stand, as has been defined before, is very contiguous. In other words, that the tree has an equal opportunity throughout that particular forest stand to grow of a particular type, and that's really not the case. That when a seed falls on the forest floor, or there's a root sprout, many influences occur. Many influences occur, and that's what we call. And so every little spot in the forest where trees grow can make a very successful growth for a tree, or it can be the death of that particular little seedling. And things that influence it are soil moisture, the climate of the area, and the actual elevation, and there's many other factors. For example, the amount of the aspect, the slope, soil type can influence it. To give you an example here, this is a picture taken in a local area, and here you can see, if we focus on this very unique looking tree right here, what that is, this here is a yellow birch. And what this yellow birch is very unique niche is that it is designed and it grows really well. If there's a stump in the forest, the very moist stump, if a seed happens to land on the stump, that particular yellow birch seed will grow on top of that stump, and the stump provides the nutrients and the moisture, and then the root systems grow down below the stump, and then over time the actual stump rots out, and then you see these stilts, which are the roots supporting the tree, and it looks like the tree kind of grew up on stilts, but it just grew on a stump. So here you can see a very focused niche for yellow birch, where it takes the opportunity to grow on these decomposing stumps. So when we look at here where trees grow, you can see here is the gradient of soils makes and is very important. And you can, one of the things, and we've talked about this at Forestry Field Camp, is the whole idea of the type of soil. And the amount of sand, silt, and clay can greatly influence the soil types. For example, if you have a high percentage of sand and coarser sands, you would find more jack pine, Pinus banksiana, or Pinus contorta, lodgepole pine. If you have a higher component of clay, Picea mariana would be found more, like, which is black spruce. Okay, and if you're more in the middle area in here, you find more Acer saccharum or more of your hardwoods. So depending on the soils, it greatly influences the type of tree that you can find where trees grow. And the competition, how do different species take the opportunity to grow better and on different types of soils, will be explained further in the course. Here is an example, and it's just gives you an idea of how, as the slopes change, and with the different soils and the different soil textures, as you see at the bottom, this just gives you an example. It is from the States, but it gives you an idea of the different types of soils one would find, different types of trees one would find over different types of terrain. So it greatly influenced other forest communities by the types of soils that are underneath. Soil moisture is a huge factor on any type of tree growth. So when you're looking at here, I've just shown a little graph that was provided by from a web source, and what we have here is 3 trees growing over 3 different types of moisture conditions. And one thing in this course, you will see lots of graphs, so please understand them. Here we have the tree at this is assuming the tree at height, the height at age 10. Okay. So what we have here is saying, if we look at the trees, and I wouldn't worry focus too much on the exact height or the age, but the idea is the influence of moisture. And here, if you look at the first one, this here, dry or xeric, or meaning, so it's a very dry location. And then the next location is mesic, meaning medium kind of moisture level, and hydric, meaning quite wet. So where do the 3 species grow? And for competition, all 3 species will grow in all 3 places. There's nothing stopping them from starting there, but where will they outcompete each other? That's the question. And when you look at it, the graph, you can see how the Douglas fir likes more, it can grow across from the more or less the dry sites to the hydric sites, Okay, so it's pretty well, and it can outcompete out west pretty well the other trees. But on the more moist sites, you will see the Sitka spruce here. It will outcompete all three species, and here you can see the Sitka spruce can do quite well. Okay. Now the lodgepole pine can be found across all sites, but where it definitely does outcompete all the other two species is on the drier sites, the sandier sites. Okay, so based on the moisture content and the soil moisture gradient, we will find different species will have different ability to compete. It's not what they like, but where can they compete the best. All trees would like to grow and do the best, of course, on this mesic, where you have just a nice amount of moisture. It's not too dry, not too wet, and that's ideal for all tree species, as you can see here, but it's not always perfect. In Canada, as you can see, if you look at this map, we have, as you go from the south, from the Carolinian forest here, and you go north. That's not a pretty arrow I drew. When you go from there, what you have is you have a gradient of climate. In this large country, we have a gradient of climate, which is, of course, from the very south to the north, and then we do have influences, of course, across the country. Okay, and that's why we have different types of forest regions across Canada, and it's driven much by going north, and as the average temperature changes, it has greatly influences the forest types. And lack of moisture influences greatly how trees grow in the prairies, and in the mountains it gets very complex. But as we have elevation, aspect, and slope can greatly influence the type of forests that are found there. Here's an example of how three species can be influenced by three things, and this is why this is an excellent little diagram. And what it's showing you here is it is a three-dimensional diagram for three species. And so when you're looking at this one here, on the bottom we have the forest expressed by hydric, mesic, and xeric. Again, very wet, medium moisture content, very dry. And then we have then we look at the forest from a low elevation all the way to a high elevation. So this is obviously for the BC type of example. So we have trees growing at a very low elevation all the way up to near the top of the mountains where they can. And then the last part of it here, what we're doing is showing you what is the amount of competition, how competitive are those trees based on those factors. So based on that, if we take a look at lodgepole pine, which is this blue layer here, you can see that lodgepole pine, which I have a little diagram here, a little picture of it. You can see that lodgepole pine can exist on dry sites, moist sites, and even quite wet sites, and it can be found from low elevation to high elevation. So it is certain, Pinus contorta certainly is found in all kinds of sites. Now, can it outcompete everything in all those locations? The answer is no, because when you look here, is that Douglas fir, Douglas fir is found and more the moister sites, okay, and it can outcompete the lodgepole pine on low elevations up to about medium elevations. Okay, that's all we need. We don't need to know exactly the elevation, but do you notice that it is outcompeting on low elevations to mid elevations the lodgepole pine? Now, does that mean that Douglas fir can outcompete everything? And the answer is no again. And here, if you look at red alder, which is a large tree out west, it is a very large tree. It is not a small tree like Alnus ruba. It's not like Alnus you would find in Ontario. Okay, speckled alder. And if you look at it here, you can see how that the red alder can outcompete both the lodgepole pine and the Douglas fir. And where does it do that? On very low elevations, on moist to wet sites. That's where it can outcompete these two following species. So depending on the species and its capability to compete, you will see, and competitiveness is based on multiple factors. That's why we have different forests, different trees, and different locations. So this is a great example of showing you of how different species can compete on different areas based on different conditions.